So now that we've reviewed that, let's start the lecture. And today we are starting now chapter 6 material, right? The start of chapter 6 is going to be a lot like, I think it's chapter 4. Chapter 4 is where we talk about congruencies, right? So,
Yes.
Chapter 4, we were talking about congruencies between segments, which is one of the things we're always interested in geometry. Is this segment congruent to this segment? The other thing we're interested in geometry is what being congruent?
Angles.
Angles. So we've done segments being congruent. Now we need to talk about angles being congruent. And that's pretty much all the congruences we care about in geometry. You say, well, don't we care if one triangle is congruent to another? Yeah, but what does that mean?
The angles are congruent.
It means that the segments are congruent and the angles are congruent. So all the congruencies that we're talking about in geometry can be reduced to, we're talking about the segments being congruent and the angles being congruent. So we've done segments. Chapter 6 is, now we're going to talk about angles being congruent, and then combining those two things together to now start talking about things like triangles being congruent. So we got to start by talking about angles being congruent. So our next postulate group, let me turn there in my notes just in case. But our next postulate group is going to very closely mirror our postulate group from chapter 4. So in chapter 4's postulate group, I can't remember what postulate group that was. Was it postulate group 3?
Can't remember.
So in postulate group 3, number 1, our first one for segments was what? Oh, come on, just think. Let's not look it up in our notes. The question is, what's still in your brain? Not what did you write down at one point. So our first postulate about congruent segments, what did it say? And then over here, all right, for postulate group.
If there must be a point, if you have two segments, there must be a point where one of those segments is congruent to the other, right? Or
Almost. So if I have some segment AB,
and you have another one.
and I have a point on a line. So, oops. Yeah, so we have a point on a line. So here's L, we'll call it the point C. And I have some segment. Then there's one and only one point on this side of C, called A prime,
Oh, yeah.
such that that's congruent to that. And there's one and only one point on this side of C, called B prime, where this is congruent to that.
Oh, yeah, the unit.
Not the unit one. That was for measuring. This is just saying you can find a segment congruent to a given segment on the line. Here's a segment, and if I've got some line, I can find a congruent segment on that line, and I can do it at whatever point you want.
Yeah.
Yeah, it's pretty obvious. I give you some point AB, and I say, here's a line, draw a segment congruent to that line. Your first question is to me, where do you want me to draw? I say, well, it's not right here. You say, okay, did you want me to draw it that way or this way? Because you can go either way. That's what this postulate is saying you can do.
Okay. You can always find a point on the line to make.
For any point on the line, you can always create a congruent segment to the left of it and a congruent segment to the right of it. Congruent to the given segment. That's it. Pretty straightforward? Now, our counterpart over here when we're talking about angles is if I give you some angle, I'll read it out to you exactly and then we'll write it out. If angle A is not a straight angle, so if we have angle A is not straight, so if angle A is not a straight angle, and R prime is a ray from a point A prime on L prime, and we have some line here, L prime, we have A prime is some point on it, and a ray this way. Then,
This is postulate group 4.
this is postulate group 5. 4 was the one for measuring in the completeness axiom. The Archimedean axiom and the
Unit 1.
The unit one was the Archimedean one, where if I've got some unit and some length, I can always count up enough units to eventually get past it. That is the Archimedean one.
Get past it or 2 as well.
Get past or 2, you're right. Get just past or 2. But, well, maybe we can keep, let's just say it. Let me just draw the picture. I think you can piece this together yourself. I've got some angle here, angle A, right?
Yeah.
And now I come down on some line, L prime. And I say to you, so here's A prime, and I say to you, using this half of the line, this ray, R, did we call R prime? I erased it for some reason. Using this ray, construct an angle congruent to that one.
It's easy.
How many are there?
What are there?
How many angles can I create using this ray so that my angle is congruent to that one?
1.
No.
2. I can create one up here,
1 there.
2. Correct. 2.
or I could have come down.
Yes.
That's what this first postulate is going to say. The same way that this one said, hey, you got a segment and a point on a line, there's 2 segments, one on either side of that. This one's going to say, if you have an angle and a ray on a line,
You can always make 2.
you can, as long as your angle wasn't straight, you can always create an angle congruent to above and an angle congruent to below.
Right.
As long as it's, oh yeah.
It's not.
Not a straight
I was
angle.
thinking,
Because if it's a straight angle,
Then there's only 1.
then there's only one.
I was thinking right angle.
And then the second part of this postulate is all straight angles are congruent.
Yes.
We don't have any proof for that. That's a given.
Right. Let's.
Excuse me. Okay, so now let me read out the postulate exactly. With this picture, I think you'll understand it. If angle A is not a straight angle, and if R prime, here's R prime, is a ray from a point A prime on the line L prime, not L1, then on a given side of L prime, there is a unique ray, he calls it S prime. There's a unique ray called S prime, such that the constructed angle is congruent to your given angle. That would make sense?
Say the last part again.
Alright. Let me rewrite that and then I'll just read out loud. Here's a picture. So if A is not a straight angle, and if R prime is a ray from a point A prime, then on a given side of L prime, pick a side, doesn't matter which side, on a given side of L prime, there is a unique ray S prime
That is congruent to.
from A prime, such that angle A is congruent to angle A prime.
Okay.
Yes.
Yeah?
Right, that makes sense.
Okay.
You're just saying S prime is just one of those rays.
S prime is one of those rays. Pick a side, any side.
And it's-
Then there's one and only one S prime I can draw, such that my resulting angle is congruent to my given angle.
Not always more than 1. So there's 2.
Once you pick a side.
Right. When you pick a side.
Oh.
Pick a side, then there is one and only one ray, such that these 2 angles are congruent.
Right.
That's the first postulate.
Yes.
Okay. Postulate 2 over here. What was postulate 2 over here?
That one was.
Congruence is a reflexive.
An equivalence relation.
It's reflexive, symmetric, and.
No, that's.
Yes, he's
Oh.
exactly right. What does it mean for a relation to be an equivalence relation?
It's symmetric.
We usually do reflexive first, but
Reflexive.
reflexive.
Symmetric, and 1 more.
What does reflexive mean? It means that AB is always congruent to itself. Every segment is congruent to itself.
Right.
2 was symmetric. What does that mean? That means that if AB is congruent to segment CD,
Then CD is congruent to.
then CD is also congruent to segment AB.
Right.
Not all relations are symmetric. Less than is an example. Less than is not reflexive, less than is not symmetric. Is every number less than itself?
No.
So these are special properties. So I'm showing you that not every relation has these properties. Only special relations have all these properties.
Right.
Okay, yeah.
Okay, and then our third one was transitive. And that was if AB is congruent to CD and CD is congruent to EF, then what?
AB is congruent to EF.
Perfect. Then AB is congruent to EF. So that was our second postulate for
Postulate group 3.
for postulate group 3 for congruence of segments. Our second one for angles. So let me give myself a little bit more room here. So postulate group, we're doing 5. So number 1 was that if we have an angle A, then that means given a line and a point R1, A prime, S prime, then angle A is congruent to angle A prime. So that was our picture for that. Number 2 here is the exact same as this. Number 2 is that angular congruence. We're going to use the same symbol, congruent, for angles and segments. Technically, we're talking about two different things. There's a difference between two segments being congruent and two angles being congruent.
Right.
We're going to use the same symbol though. So they being two different things, we're going to use the same symbol, and they behave so close to the exact same way, it makes natural sense to use the same symbol.
Right.
So the next one is that congruence is an equivalence relation, same thing. So it's the exact same thing as what we have over here, we just write it a little bit different. We see angle A is always congruent to angle A. Here we say if angle A is congruent to angle B, that implies angle B is congruent to angle A. And transitivity, same thing. If I have angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. So that's our second postulate for angles. Pretty much identical so far, right?
Yes.
Do you remember our third postulate down here? This was the one about adding and subtracting things together.
Oh, yeah. If you have and like EF.
Yeah, it's hard to just say it all in words, but
Yeah.
so it told us that if AB is congruent to A prime B prime, and BC is congruent to B prime C prime,
Then A prime C prime is congruent to AC.
perfect. The way we say that with high level language is equals added with equals are equal. And we had the subtraction version. If I know AC is congruent to A prime C prime, and I know that AB is congruent to A prime B prime, then
Minus AB from AC, then you know that BC is congruent with DC.
then I know BC is congruent with B prime C prime. The high level way we say that is equals subtracted from equals are equals. Okay, so we've got a similar thing now over here for our angles. It's the same thing.
Oh, so postulate group 5 is just saying the same as postulate group 3, but just with angles.
Right.
Exactly.
Yes.
Exactly. So that's all we're trying to get from here. So this one's broken up in 3 parts. Let me just draw the pictures. So we have a picture. Let me try and keep my labeling the same. So I call this A, and we draw that through. And we call this part B, and we call this part the angle C, and try and draw the same looking picture over here. Call this A prime, call this B prime, call this C prime. Okay, so here's our two angles. So it's broken up into three parts. So part A, if I know that, I'm not sure which order the author does it, maybe I should keep the order the same. I'm not sure if I even wrote it down the same way he did, but we'll just try it, doesn't matter. Three cases here. If angle A is congruent to angle A prime, and angle B is congruent to angle B prime, then what?
Then, wait.
If A is congruent to A prime, and B is congruent to B prime,
Then C would be congruent.
Then C is congruent to C prime.
then C is congruent to C prime. And again, that's equals subtracted from equals are equals. So this was saying we subtract the angles, right?
Yeah.
Alright, let's look at the next one. The next one's almost identical. If angle A is congruent to angle A prime, and angle C is congruent to angle C prime, then what?
Angle B is congruent to angle,
Yeah.
Angle B prime.
Angle B is congruent to angle B prime. And again, is that saying addition or subtraction?
Subtraction.
Again, that's saying subtraction. So we say subtraction twice. There's two different ways you can subtract angles. We'll have them both as postulates so that you don't need to worry about, oh, can I only subtract the top one? Or can I only subtract the bottom one? Do I need to figure out how to flip this thing so I can subtract it? So, and then adding is always adding. So the last one is adding. So this one is if angle B is congruent to angle B prime, and angle C is congruent to angle C prime,
And
then
angle A would be congruent to angle B prime.
angle A is congruent to angle A prime. And you see how that one's talking about addition.
Right. Yes. What if there's another angle in angle A prime?
So you're saying, what if our angles broken up like this?
Into three different, yeah. And so you have angle C prime congruent to angle
Then you can always do the same thing again.
there.
Because you can look at just this picture right here first. Right? You can look at just this picture.
Yeah.
And if you had some other picture you're correlating it with, you can use this one to add these two angles together into one angle that you know is congruent to whatever. And now you have this angle and this angle. So if you have 4, you can always look at it as pieces of 3. Or sorry, if you have 3, you can always look at it as pieces of 2. And if you need to combine them, this is one that tells you how you add together.
So let's say that one's A double prime.
Yeah, so
Well, I'm wondering.
I'll run through a simple problem like what I think is at the heart of your question. So let's work with our picture here, and let's just add to it. So we're no longer doing the postulate, we're coming up with a problem just to help us think.
No, I'm saying A prime doesn't have that other angle. Is that possible? So A has that third angle.
So A has D
A
here.
prime doesn't have that third angle.
Okay.
A
So
prime
like
said
this.
A prime is congruent to A.
Yeah,
No,
I'm
they're not.
saying.
So if this is our picture, then we know that if B and B prime are congruent and C and C prime are congruent, then this angle right here
Must be congruent.
is congruent to this angle right here. And now we have a labeling problem because angle A, we would typically want to include D. So now you're going to have to, in your picture, somehow label this thing, either put points on this side or call this somehow R1 and R2.
Right,
And
so
it's this angle that's congruent to this angle. So you just have to label it so it's clear to your reader.
Right.
I got you. It's just one.
Yep, no, good question. Okay, anything else?
That I can think of.
All right, then let's prove our first theorem. Our first theorem is that if two angles are congruent, then so are their supplements. So maybe we'll keep that as reference, even though it's kind of ugly. Just come over here and prove everything so that we can reference our postulates as needed. Is that whiteboard a little longer? Okay. Trying to be more efficient with our space here. So, doing theorem 6-1. Let's write out what it says. If two angles are congruent, comma, then so are their supplements. Okay, let's draw the picture for this. We'll draw it down here. So,
It's the same one over there, right? On postulate 3.
same one over there, postulate 3.
Or not postulate 3, postulate 5, problem 3.
Let's see. So I'm going to call this angle A. This is angle A prime. Remember, the supplement is the angle such that together they give you a right angle.
Oh, a straight.
A straight angle, thank you. Yes. So,
But a right angle too, right?
No, that's a different word, that's.
a right angle, no, definitely not a right angle. I messed up bad.
The right
So
angle
there's
is
angle
so
A.
complementary though, right? There's a
Here's
term for
angle
right angle, what is it?
Comma.
Complementary, right?
Okay. So one,
I'm wondering.
let angle A be congruent to angle A prime, comma, and let angle B and angle B prime be their supplements. Okay. So setting up this picture.
Yes.
What am I trying to prove? I'm
If
trying
A
to prove
prime
that
is congruent
angle
to
B
A.
is congruent to angle B prime.
Right, but
Because
if A is congruent to A prime, then.
So I know A is congruent to A prime, so I know this is congruent to this.
Yes.
I'm trying to show that this is congruent to this. How am I going to show that?
Wouldn't you set it up in degrees where a straight angle?
We have no notion of degrees. We have no notion of measuring angles yet.
That's next.
Yet, or? So
We
you can't
will.
use that yet?
Remember that we were talking. Remember, we had chapter 4, which was talking about congruent segments, and then chapter 5 was measuring segments.
Yes.
So
Why
chapter
they-
6, we're
why
going to
they
be
go
talking
vice versa?
about what?
Why didn't they go vice versa? So you measured segments before you figured out that they were congruent.
Because you don't need to know the number to do the geometry.
It just makes sense. Is what.
Yeah. When we introduce the measurement, we kind of have to drift away from geometry a little bit.
Yeah.
How are you supposed to measure something without the geometry?
And so,
Use anything more.
well,
You don't know.
it's assigning numbers to it. If you go and you look at like Euclid's work, for example, he doesn't ever work with measurements. He doesn't really need to.
Right, so the reason why is to show that you don't need the numbers.
We're the reason we have the measurement section is because
I'm not saying why we need to measure, I'm saying why we did congruence before we did measurement.
so the reason we did congruence before measurement
It's to
is
show that you don't need the measurements, it's to show you can be congruent.
that works. Yeah. There's a lot we can talk about without getting the precise measurements, without getting the numbers. We don't need the numbers in there to do the geometry.
Right, that's fun.
Okay. Anyway, so yeah, we will get to measuring angles, but we don't have that yet. Right now, all we have are our congruence theorems for angles, or our congruence postulates. So you can bet good money that we're going to have to use something written over there to do this. Now, maybe you're confused because I didn't write the second part of this. So part of number 1, so 2 is just the same as over here. Part of number 1 is and all straight
Angles
Angles
are
are
congruent.
are congruent. Should have written that.
Right, so thus, if angle A is congruent to angle A prime and the straight angle
use
and B, how do you say that? Angle B plus angle A is congruent to,
Would be a.
has to be congruent to angle B.
Yeah, maybe
prime
we
plus-
should label these really quick.
Is there a property for when you're adding like segments together or
Angle A,
or
angle A prime.
angles together?
L and L prime be the straight angles.
As long as it's a straight angle. Geometry.
This is L, this is L prime. Right?
Yep.
Okay. So now, 3, what do we do? What do we say?
Angle. Well, you already stated your
Angle A
Since angle A is congruent to
congruent to angle A prime.
angle A prime, and
angle B.
B is congruent to angle.
we don't need to know that. That's what we're trying to prove.
And
angle
line L is
A
a straight angle.
plus angle B makes a straight angle. Would you say that?
And we can say it a little bit better, and angle L is congruent to angle L prime.
Congruent to L prime.
Which is
Then
straight
what?
angles.
Then
Yeah, those are straight angles.
There
So
must
I know
be-
L is congruent to L prime. They're both straight angles.
There must be an angle that makes angle A congruent to.
I know this piece is congruent to this piece,
Yeah.
and I know this whole thing is congruent to this whole thing.
So there must
So
be an
then-
angle which makes A congruent to L, right?
What?
So
Look, come back to this picture. If I know that A is congruent to A prime, and I know that B is congruent to B prime, then I know that
Angle C is
Angle,
congruent to C
uh,
prime. So then angle B is
angle
congruent
B-
to angle B prime.
angle A. Oh, angle L minus angle A.
there you go. Equals subtracted from equals are equals.
Yes.
This whole angle's congruent to this whole angle. That chunk's congruent to that chunk. Therefore, this chunk has to be congruent to this chunk. So equals subtracted from equals are equals. So 4. Oh no, we have it here. Since that's congruent to that and that's congruent to that,
Then angle B.
then by 5, 2, comma, angle B is congruent to angle B prime.
Yes. Correct.
Okay, there's theorem 6.1. Make sense?
Yes.
Alright. Theorem 6.2 is vertical angles are congruent.
Vertical angles are congruent.
Vertical angles are congruent. Yeah.
Okay.
So,
So vertical.
So 90-degree angle.
so I was picturing this. Do. You had L prime,
Oh, never mind.
A. Oops, L prime.
Oh.
This was A prime, A. I don't know if we'll need to reference this again. B prime. Just scribbling it up here. Okay, so let's go on to our next one. Theorem. Theorem 6.2.
Wait, that's a vertical angle. What's
No, no, he's just rewriting.
All
that. There's
vertical.
just one.
Oh.
Picture.
Angles are congruent. All vertical angles are congruent.
It's vertical mean opposite side of the line. Oh,
That's
that's
all
what
I
vertical
agree.
is.
We'll draw our picture down here. So
Yeah.
call this
Oh, L.
L and L prime. And we'll call this right here angle A, and we'll call this angle A prime. So 1,
How many lines does this have?
angle A, I don't know, and angle A prime be vertical angles on L and L prime.
What if you don't have a straight line?
You only have vertical angles when 2 lines intersect.
No, I'm saying what if your line's like where it goes like this? So you have a line through and it goes like this, and where it intersects. So like
What is a vertical angle? So you have 2 lines that intersect at a point,
okay.
and then you take 2 opposite side angles. Those are vertical
Yeah,
angles.
that's vertical. I'm saying what if you have an angle like this?
Oh,
Or
I'll get to that later.
a drawing, so you have one line, and you have a line that goes like this.
Is that a line?
Yeah, I mean, yeah. Wouldn't it be?
Strictly speaking, it turns out all our lines are straight.
What proves that? You said, well, I thought
Line's
you said
an
a
undefined
line.
term.
Yeah.
It is. Line is an undefined term. It turns out all our lines have to be straight.
Yeah,
Because
because
there's only one
intersect
line
once.
that can take
Yeah,
two
but that
lines.
intersects that line once.
Yeah, but what happens when
I'm
the line
saying what
is?
makes it, I'm just picking.
I know what you're saying. So you're saying, I drew the picture like that. Why couldn't I have drawn the picture so it comes up and goes over like that?
Yeah.
I could have. Okay, I draw my picture like that. It doesn't change anything.
Does that make it congruent though?
Are these vertical angles?
Yeah.
Then I'm going to prove that they're congruent.
Okay.
Pictures lie.
Okay.
It's going to break your intuition to draw lines like that, but it's not going to hurt our proof in any way, shape, or form. Okay, so I'm going to use this picture. You can think about with this picture. A and A prime, and everything I'm going to say is going to hold. Because that means that this angle right here is a straight angle. The angle of a line is a straight angle.
Yeah.
And this angle right here is also a straight angle, right?
Yeah.
Okay. Coming back to our picture. 2. Let angle B be the supplement of angle A, comma, and observe that it is also a supplement of angle A prime. So write out the supplement of A, doesn't matter which one you do, and call it angle B. Angle B is also going to be a supplement of A prime.
Yes.
Yeah. Right.
Right.
Yeah. You're right.
A prime and B together make a straight angle. A and B together make a straight angle.
Yes.
Even from your picture up here, if this would have been our B, A prime and B make a straight angle because you said this is a line. And A and B make a straight angle because this is a line.
Yeah.
So B is a supplement to both those, right?
So you're saying that squonky thing is one line?
Yeah. Pictures lie. Then, maybe make this explicit then, since angle B is congruent to angle B, then angle A is congruent to angle A prime by theorem 6.1. What does 6.1 say?
Oh.
If two angles are congruent, then so are their supplements. Angle B is congruent to angle B. So its supplements are congruent to each other.
Right.
Yes.
So my two angles are B. Since this angle is congruent to this angle, then the supplement of this is congruent to the supplement of this. What's the supplement of this? A prime. What's the supplement of this? A.
Right.
Oh, yeah.
So, and notice that still works with the crazy picture we have up there.
Does that prove that though?
Yeah, that's it. We were just trying to prove that angle A is congruent to
Angle A prime.
angle A prime. Vertical angles are congruent.
All those are.
And they're sub.
What?
I forgot what a vertical angle was. Right, okay, that makes 100% sense now.
Okay, 100% sense.
Which means B prime or B would be congruent to B prime.
Right, it's a vertical angle. If B prime was a vertical angle to B, yes, now we know that it has to be congruent.
Alright, so now we get our first definition of the section. Definition, I can't remember, he resets the numbers for definitions, 6.1. Definition now of a right angle. An angle
That has 90 degrees.
that is congruent
To itself.
To its supplement.
to
or
its
to
supplement.
That's so sweet.
And you're proving that? Oh.
Is a right angle. No, it's a definition.
Definition.
Yeah.
That's what we mean for an angle to be right. It's congruent to its supplement.
Yes.
Alright. Now we introduce our last postulate of this chapter. The postulate is the side angle side postulate. So This is
Oh my
postulate.
gosh, side, angle, side, so SAS. This is where we start getting into it.
Oh, I
So angle, side, side.
Okay,
Angle, angle,
thank
side.
you for saying this. When we get to our theorems for proving that triangles are congruent to each other, we're going to have a side, angle, side congruency. We're going to have an angle, side, angle. And we're going to have a side, side, side.
Don't you have an
Those
angle,
are gonna
angle,
be the-
side?
Angle, angle, angle. Or an angle, angle side.
Yeah, you have all that. You have
Well, these are going to be the three that we're proving in this section. And
yeah, you have an angle.
the
side.
point here is that we're have a side angle side congruency theorem for triangles. We are going to introduce a side angle side postulate. These are not the same thing.
They are not?
No. So we will prove, I think that this will be the theorem that immediately follows. No, that's isosceles triangles. But it'll come soon. 6-4 is proving this. Theorem 6-4. So not next one, but the one after that. So keep in mind that is not what we're talking about. So postulate 5-4. This is the side angle side postulate, is what it's often referred to. Side angle side postulate. Okay, what does this postulate say? This says if two triangles, triangle A, B, C, and triangle A prime, B prime, C prime, are such that angle A is congruent to angle A prime, AB is congruent to A prime, B prime, comma, and AC is congruent to A prime, C prime, comma, then angle B is congruent to B prime and angle C is congruent to C prime. Then angle B is congruent to angle B prime, and angle C is congruent to angle C prime. Okay, let's draw the picture for this and make it make sense. So I have two triangles. We have triangle A, B, C, and we have triangle A prime, C prime, B prime. Okay, if I know that this angle is congruent to this angle, this side is congruent to this side, and this side is congruent to this side, then what do I know? I know angle B is congruent to angle B prime, and I know angle C is congruent to angle C prime. That's what it gives us. It does not give me that this side is congruent to this side. It turns out that will also be the case. That's going to be a theorem that we proved, and that's what we'll mean by the side angle side theorem for congruency of triangles.
Okay.
So it just gives you that the other two angles are also congruent. If you know a side angle side, then you know the other two angles. That's the postulate.
Is that, oh yeah.
Any questions on that?
No.
Alright, so let's move. I'll go
Those
ahead.
would be equal triangles, right?
Congruent.
Or do you have to have
Congruent triangles.
everything?
Remember,
Yeah.
when we say that one triangle is equal to another, we're saying that they are identical.
The same exact.
They're exactly the same triangle.
They're exactly the same triangle.
A prime is A. B prime is B.
Right.
C prime is
So,
they're congruent.
these are congruent triangles. We haven't written out a definition for congruent triangles yet, but it'll mean all the side lengths are congruent and all the angles are congruent.
If you don't know any side lengths, would it still be congruent?
No, that would be similar triangles.
What if you don't know any of the angles?
Then you have two triangles. Oh, but you have all the
You
sides?
have all the sides.
Then they're going to be congruent, and that's going to be our side, side, side.
Okay. Oh, so all three of those are what make congruent triangles?
Those aren't the only things.
No,
but
I'm saying, but like,
those are three that we'll be proving in this chapter.
if you have side angle side, that would be a congruent, those would be congruent triangles.
Yes.
If you have angle side, that would be congruent. And then side 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 would be congruent.
Yes. Okay. Let's see. On now to definition of an isosceles triangle. Okay. A triangle is isosceles. How do I write it? Just like that. Don't label anything. If two of its sides are congruent. You probably already knew this, but what does it mean for a triangle to be isosceles? It means two sides are the same length.
Yeah.
Does it mean that these two angles are the same?
No.
No, that's not what it means. Turns out that will be the case, and we'll prove that, but that's not the definition of an isosceles triangle. It has to do with side lengths. What about if we drew here an equilateral triangle? So that's the same length as that is the same length as that.
All the angles.
Is that isosceles?
No.
No, it's not isosceles because it doesn't have two sides congruent.
If and only two sides?
Oh, wait, it does have two sides congruent.
Yeah.
Yes, this is isosceles.
Okay,
It's a
so
special
equilateral
case of an
is
isosceles.
So it's,
So all equilateral triangles are isosceles. They have two sides equal to each other.
two sides or more?
It's okay if you have more. Do you have two?
Yeah.
If you're a millionaire, I ask you, do you have $2?
Yes.
Yes.
Of course. All right.
Depends what you mean by millionaire.
What's that?
Depends what you mean by millionaire. It could be exaggerating. I could have $1 and like.
If it is given that you are a millionaire,
by the world's definition.
okay. Well, just the definition. That doesn't mean to be a millionaire. It means you have a net worth of $1 million.
Or like, you could owe a million and $1. And I could have $1, and to you, since you owe this much money, I could be a million.
Oh, you could still have $2 without having a net worth of $1 million. That's true.
Well,
He's trying to include the definition of millionaire.
All right.
I'm saying, yeah, like,
You're saying that's all in assets and you don't have any money in the actual
like
bank?
what is million, you know? It's
What
just
is
a
million?
name. Yeah. What is million?
Yeah.
It's
What is
1,000 times 1,000.
That's just a name though, you know?
Well, yes.
Just like a line, it's,
If we go back to our numbers, if we were doing algebra, we have two undefined numbers, 0 and 1.
yes.
We have two undefined operations, plus and times. Now, what's the definition of 2? 2 by definition, 1 plus 1. What's 3 by definition? 2 plus 1. Dot, 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 dot. What's 1 million by definition?
What is 1 by definition?
99,
1 plus 0.
99,999.
No, 1 by definition is not 1 plus 0.
But what I'm saying
Huh?
is 1 million is just a name.
You want 1 by definition to be 1 plus 0? Maybe you can identify the problem in that. Look at the definition.
Well, same thing as multiplying 1 plus 1.
What
Or
I'm
adding.
saying is,
How do you make 0 though?
No, you're way overthinking it.
what I'm saying,
I'm defining this symbol.
Right. Using itself.
Circular reasoning.
well, no, what I'm
But
saying
you
is,
prove that this is a theorem. Oh, no, you don't. That's given. We're 0. That's one of your axioms.
what I'm saying is 1 million is just, not 1 million. Million is just a name, you know? It could be Papa Duke.
Yeah, million is just a name.
Yeah.
It's,
So millionaire
so is
is
1,
just a name.
so is
to
2,
represent.
so is 3, so is 4.
Yeah, so is
All of them are just names.
What if I spoke Spanish and I didn't know what the hell millionaire meant?
Well, if you spoke Spanish, then you wouldn't have said 1, you would have said uno.
Yeah.
So all of it is
What
just
if you
names.
said 1? Yeah, it's,
Identify as a millionaire.
Yes, words are words, and words are
Yeah.
nothing more than words.
That too. Now in today's generation, I could say I identify as a millionaire, and I could.
And so we have words for that. If you identify something contrary to reality, we now have to make a judgment. Did you do it intentionally or unintentionally? If you did it intentionally, we say you're a liar. That's what it means. When you identify something contrary to what it actually is, that's what a lie is. If it's intentional. If it's unintentional, we say you're mistaken. If you're persistent in it, we say you're delusional.
You guys, this is going on YouTube.
Of course, schizophrenic.
I'm not worried about that.
I don't know.
So, yeah, people who identify as something contrary to reality are people that are mistaken or most likely delusional if they're persistent in it. Well, schizophrenic is different, but a lot of delusional people. They delude themselves into thinking something. Oftentimes, people are, I mean, you think of it as an extreme thing, oh, you're delusional. Sometimes people are delusional about simple things. You know, they notice that they have a growth on their skin. And they don't go get checked out. They're intentionally putting the problem up. They're pretending that reality is something different than what it is. They're being delusional. So, you can be delusional in a simple thing, you can be delusional as an extreme case. Someone sits there identifying as, no, I'm perfectly healthy. Well, there's a little bit of reality screaming to the contrary. You should probably go get checked out. So, it doesn't matter how you identify things. What matters is what it is.
Bring that up in an LGBT.
Yeah, it's a bunch of nonsense. And now you know why it's a bunch of nonsense.
This is going viral. Math teacher rips into it.
I'm sure there's plenty of them doing it.
Good cancel.
Oh no, no one's gonna watch my videos. Okay.
Sued for billions.
To prove that transgenders are delusional.
You're gonna have to
That's
start
literally what they are. It is called gender dysphoria. That's what every sane human being called it up until 10 years ago. Gender dysphoria. It was a mental illness. It was something you would help people overcome. But our next theorem, Theorem 6.3. Theorem 6.3. Now we are proving that isosceles triangles, the base angles of an isosceles triangle are congruent. Oh, I didn't say anything about the base angles here. A triangle is isosceles if two of its sides are congruent. The angles opposite the congruent sides, are base angles. Yeah, I forgot to say the base angles.
The angles opposite of the congruent side.
So draw an isosceles triangle here. Here's the congruent sides. What's the angle opposite this side? That's this angle. What's the angle opposite this side? That's this angle. Those are the base angles. This is not a base angle. That is. Has two base angles, one not. And so with an isosceles triangle, we have the notion of the base of the isosceles triangle. Okay, so now theorem. Where are we on? 6.3.
Wait.
Go ahead. The base angles of an isosceles triangle. Triangle are congruent. I don't know why it's like me there. You know, I did something weird. Congruent. Okay. So one.
Can I ask my question real fast?
Yep.
If base angles are made up by those congruent sides, then how are those sides opposite? How is that the base angle
Here's the
opposite
side.
of the congruent side?
Here's the side.
Yeah.
What angle is opposite that side? This angle.
How do you know that though?
Oh.
This angle
Oh, because it doesn't make up.
is opposite this side.
It's an angle. It's the angle that doesn't.
Right, this side
made
is
up.
not part of that angle.
Okay.
And this side is not part of this angle. And so those are the base angles.
So if all the sides were congruent, all the angles would be base angles.
Yes.
That makes sense.
Okay. So the base angles of an isosceles triangle are congruent. That's what we're proving. So let ABC be a triangle such that AB is congruent to AC. So we're setting up our isosceles triangle here. So I know that. Here's ABC. I think I did A up here. A, B, C. So I know this side's congruent to this side. You with me?
Yeah.
Now I'm going to do a double labeling of the same triangle. A double labeling. I'm going to reset up this triangle. I'm going to call this a point A and A prime. I'm going to call this a point B and C prime. I'm going to call this a point C and B prime. I'm going to draw them on top of each other.
Why just be really confusing?
Just to get really confusing. And let me draw it now as two separate triangles. They're really the same. Let me draw it as two separate triangles.
These are the same triangles.
They're the same triangle drawn on top of each other. Try and draw it just a little better. Not great. So here is A, B, C. Here is C prime. Here's B prime. Here's A prime. And I know that this is congruent to this, and I know this is congruent to this, right?
Which means C would be.
And I also know that this angle right here is congruent to this angle, right?
Yes. And that's what. And you're proving that B is congruent to C prime.
I'm trying to just prove that B is congruent to C. I'm trying to show that these two are congruent. I'm trying to show that the base angles are congruent.
I thought you already did that.
No.
By the definition.
By definition of isosceles triangle, the sides are congruent. We're trying to prove that the base angles are also congruent. We just defined what the base angles were.
The angle. Oh.
We don't know that they're congruent. We need to prove that.
Okay.
Okay, so I have these two pictures here.
So I said.
I'm going to flip this triangle on how I draw it. So I'm going to put B prime here and C prime here.
Okay.
So here's both my triangles are in this picture. How do we get it together? We flip that like that and then bring it down. So they're really the same picture, right?
Yes.
Okay. So then, what do I know? I know that BC is congruent to B prime C prime. I know that angle A is congruent to angle A prime. And I know that AC is congruent to A prime C prime. So what do I know? What does that give me from our postulate here? What was this postulate?
It was saying that.
If I know a side, an angle, and a side,
then you know. That
then I know the other
angles
two
are-
angles are congruent to each other.
Yeah.
So which angles do I know are congruent to each other here?
B and C.
I know B is congruent to what?
Oh, A
C
and A.
prime.
A and A prime.
I know B is congruent to what?
C prime.
B prime.
B prime.
B prime. Order here matters. Since I showed BC is congruent to B prime C prime, and angle A is congruent to angle A prime, and AC is congruent to A prime C prime, then the angle associated with these segments is congruent to the angle associated with, and the angles associated with these segments are congruent.
Okay.
You're looking too much at this picture. Look at this picture. I know that AB is congruent to A prime B prime, and I know that angle A is congruent to angle A prime, and I know that AC is congruent to A prime C prime.
Right.
So I know that angle B is congruent to B prime. It turns out in my special picture, B is also congruent to C prime, but that's a special picture. But from the information I have listed out here, all we know is that angle B is congruent to angle B prime, and angle C is congruent to angle C prime.
Yeah.
You with me?
Yeah.
Okay.
How do you know that,
Now,
though?
do I know that BC is congruent to B prime C prime?
Yes.
Do I know that angle A is congruent to angle A prime?
Yes.
Do I know that AC is
Okay,
congruent
so you're
to A
saying
prime C
because
prime?
of postulate.
Then by this postulate says those exact things. If I have the angle AB and AC, then I have B and C. So by that exact postulate, then I know these two things. Okay, now let's come back and look at this picture. So I know that angle B is congruent to
Angle B prime.
angle B prime,
Same thing with C and C prime.
which is the same thing as angle C prime. Oops, which is the same thing as C, I mean.
Right.
So I have angle B is congruent to angle C, which is what I'm after. The base angles are congruent. Alright, so let A be C such that AB is congruent to AC. 2. Let, it's very important I get the ordering of these letters right. Let triangle A prime C prime B prime equal triangle A B C. So I'm saying C prime is the same point as B, and B prime is the same point as C.
Right.
It's very important, the ordering that we put on these letters. I couldn't have said, let triangle A prime, B prime, C prime equal triangle ABC, otherwise I would change my picture over here. So it's very important that I have these letters in the order that I have them.
Okay.
Alright, 3. Then,
And by transitive property, that's true. Number 2.
no, I'm just relabeling.
Oh.
That's all I'm doing. I'm saying, let's add a second pair of labels to each one of these points.
Oh, yeah, okay.
Okay, so then I need to show that these three relations hold. So then BC is congruent to B prime C prime. Maybe make something a little bit explicit here. So then using our relabel triangle, what are our congruent sides?
C and B. C prime and B. C prime and B, and B prime and C. Wait,
The ones with the A's.
yeah.
So I still know,
A to C prime.
let that equal that, and maybe just put it as a side note here. We still have A prime B prime is congruent to
A, B.
A prime C prime in our new relabeling.
Oh, yeah, okay.
You with me?
Yeah.
Okay, so then AB is equal to, in terms of our prime, what's AB?
A prime, C prime.
A prime C prime, which is congruent to A prime B prime. Right?
Yeah.
So I showed AB is congruent to A prime B prime. Oh. No wonder you guys were confused. I put B's here. These are supposed to be A's. Sorry. Probably makes a lot more sense now.
You restated that twice.
Oh my goodness. The B goes here. Alright.
Okay, that makes sense. Okay. Makes so
Holy
much
cow.
more sense.
A side is congruent to a side, an angle is congruent to an angle, and a side is congruent to a side. That's what we're trying to say. Wow, that was terrible. Okay, a lot of things are probably cleared down. We're to help if I write stuff right. So if we have this, this, and this, and we have these two, and then using this logic down here, we have angle B is congruent to angle C. So I'm just trying to get this logic here. So I got that AB is congruent to A prime B prime. Okay. Angle A, I know is congruent to angle A prime because they're literally the exact same angle, right? That's from the reflexive property.
Right.
Oops, is congruent to angle A prime, comma, and let's see, we need to show that AC is congruent to A prime C prime. So AC is congruent to, or AC is equal to, let's go back to our prime coordinates. What's AC in terms of our prime? A prime, B prime.
Oh, yeah.
So AC is equal to A prime, B prime, but I know A prime, B prime is congruent to A prime, C prime. So I get that AC is congruent to A prime, C prime. So for, then by postulate V-4, comma, I know that angle B,
You don't have 5-4.
postulate V-4,
Oh.
side angle side.
I didn't see it.
It's okay if we would say just by side angle side. Sometimes we want to say that for our congruence relation, but. So then by V-4, angle B is congruent to angle B prime. And angle C is congruent to angle C prime. That's what V-4 gives us, right?
Yeah.
If we have this sides congruent, that angle congruent, and those sides congruent, then we have the remaining two angles are congruent. So 5, then angle B is congruent to angle B prime is equal to angle C, which gives me angle B is congruent to angle C, which is what we were after. See that?
Yes.
Okay. Let's do our next theorem now, our side angle side theorem for congruence. I don't need any of that. Kind of squish it here. Okay, so
When you say side angle side, does that mean the sides are congruent?
yeah, when we say side angle side, we mean they have two sides congruent and two angles congruent and then two sides congruent again, in that order. So it has to be
you have a side-
sides next to an angle next to a side,
That
all
is
congruent. Then the whole triangles are congruent.
Okay.
So what am I going to prove? Draw the picture down here for what we're going to prove. Just get that. I'm going to prove that if we have two triangles, this one is A, B, C, and this one is A prime, B prime, C prime. If I have two triangles, and I know that they have a side, an angle, a side, all congruent. So a side, and then it has to be an adjacent angle, could be this one or this one. We're going to choose this one. A side, an angle, and then the other adjacent side to the angle, all congruent. Then the whole triangle is congruent. Oh, we need a definition of congruent triangles. So we're going to get to that. Missed two definitions. Sorry. Definition 6.3. Definition 6.3 is going to be the definition of a midpoint. The midpoint M of a segment is the point M in AB such that AM is congruent to MB. So
You're saying it has.
take some
It's
segment,
the same thing as definition 6.2. No, not 6.2, 6.1.
take some segment. Definition 6.1.
It's just basically the same thing as, it's like the definition of congruence for a segment.
Or definition of a right angle.
All right. It's exactly what you would guess. If I said, here's segment AB, where's its midpoint?
It's exactly in the middle.
It's exactly in the middle. What does exactly in the middle mean for point F?
Point,
It's
same
the same
outward,
That's
same
congruent to
outward.
that. The sides are congruent to each other.
Yeah.
So the midpoint of a segment AB is a point in the segment. Has to be in the segment. You can't pick a point not in the segment. Such that the first half of the segment is congruent to the second half of the segment. Okay, and then definition 6.4. Triangle ABC is congruent to triangle A prime, B prime, C prime, if and only if AB is congruent to A prime, B prime, comma, AC is congruent to A prime, C prime, comma, BC is congruent to B prime, C prime, comma, angle A is congruent to angle A prime, comma, angle B is congruent to angle B prime, comma, and angle C is congruent to angle C prime. Sorry. So that's what it means for two triangles to be congruent. All three of their side lengths are congruent. All three of their segments are congruent, and all three of their angles are congruent. That's what it means for two triangles to be congruent. Right? Let's make sure we understand this. Okay, so we have A, B, C, D, E, F. So we have these two triangles. Imagine I tell you that this angle is congruent to this angle. This angle is congruent to this angle. This angle is congruent to this angle. This side is congruent to this side. This side is congruent to this side. And this side is congruent to this side. So you have all that information. Question: is triangle ABC congruent to triangle DEF?
Yes. Yes.
No. The orders are wrong. ABC is
Oh.
congruent to DFE, not DEF.
Yeah.
Good. This is a false statement.
Yeah.
We have to switch the F and the E here in order for it to be a true statement.
Yeah.
Right. Now that's true.
Now it's true. So the order that you write those things out in matters. When I say that this is congruent to this, I mean that thing's angle is congruent to that thing's angle, that thing's angle is congruent to that thing's angle, that thing's angle is congruent to that thing's angle. And I mean that segment is congruent to that segment is congruent to that segment, and that segment is congruent to that segment.
Yes.
And that's all the information coded in there. So the order very much matters.
I agree with that.
Yeah. Okay. Should we just, how are you guys feeling?
I also need to use this.
Let's, we can end it there with that postulate. Next time we'll start by proving side angle side. That will be a good theorem to reintroduce us to the postulate, because really this postulate is the only big changer for this chapter. The other three postulates are almost exactly what you would have guessed.
Right, yeah.
So we'll start with that next time. We got as far as, you should be able to do exercise group 6.4. Maybe we got through 6.5.
So we're doing 6 1.
See, chapter.
6 5.
This is a big chapter. This will be one of the harder chapters we cover in the book.
How many chapters do we do in the book?
6.4. Oh, you can also do 6.5.
How many chapters do we do in the book? All?
Yeah. That's what you do. You go through a whole textbook.
I just wanted to do the special.
Didn't do number 1.
Oh. You could probably even do 6.6.
Oh, that's nice.
You can also do exercise group 6.6. Okay.
Are there any proofs in these?
We shouldn't be to any heavy proofs yet because you don't have your congruence theorems for triangles. So we're on theorem 6-4. Oh, you can also do 6-7. 6-7 only has one problem. That's why I didn't see it.
Cool.
I think a bunch of these, some of them are big. 6-6 is big. But I think most of them are going to be questions like, look at this picture and see if you can figure out what's congruent to what. So I think it's going to be a bunch of really straightforward problems. Not any hard ones. Okay, so we'll call it there.